Hello, friends. Welcome to this live stream. This is Akulmach Science Show, and as you have noticed, looking at the topic, we are going to discuss about something very intriguing, and this is about the neutron stars. Neutron stars are basically very intriguing objects in our space. We will discuss about the next big thing which is happening with regard to neutron stars. We all know what are neutron stars, etc. So we are not going to go into in-depth analysis of what the neutron star as an object is, but what we can find out more about it, what are the latest findings, what is going on in the area of understanding black holes and neutron stars, what are our new gadgets. All of these things we will discuss today. So moving on, the bizarre reality of the neutron star mountains is the core subject. So you know that neutron stars are very dense, very intense objects with very extremely high gravity, very high gravity. It exerts to its surrounding. The gravity of neutron stars is so high that it actually drags the space around itself, which is also known as frame dragging. So if something is very close to the neutron star, it will not fall into the neutron star straight, whereas on the other hand, it will get disintegrated because of tidal forces imposed by the gravity, and then it starts spiraling inwards. Eventually, after some few thousand years, it will actually emerge on the surface of the neutron star. Considering this, that the neutron stars are entirely made of neutrons, and why the neutron star is called neutron star, because there is no other material like electrons or protons which are present on the neutron star, and everything is made of neutrons. Very dense object, many times the mass of sun, up to the at least twice or up to 2.5 times the mass of sun, concentrated in a city size ball. And when the gravity is so high, there is no material other than neutrons are available, and there is so much compactness in the neutron star. It is said that the neutron stars can also may not have the mountains, and it has to be perfect spheres that we can find in the universe. Why the scientists used to think that way? Simply because when the pressure on the surface of the neutron star is immense, then there will be no imperfections on the surface, because everything is getting pulled inwards because of the immense gravity, and therefore it was assumed that neutron stars are perfect spheres that can exist naturally. However, as our understanding of the neutron stars have improved, we have started to question our belief, which we started our theories with, and therefore there could be imperfections and there could be mountains. But how do we understand these mountains? In order to basically know how we can study, I think we will actually spend some time in understanding why there could be mountains, what are the processes which are involved in creating these mountains. Okay, so first of all, let's look at the a principle known as Pauli's exclusion principle. Pauli's exclusion principle is basically a theory which says that in case there is a object occupying some position and place and some real estate in the universe, then that real estate is reserved for that particular object, and no other object can actually enter that object. So this is a Pauli's exclusion principle in a very layman's language. Now, if we have to basically extrapolate on this Pauli's exclusion principle, it actually means that when we say object, it also applies to microscopic atomic particles. So let's look at very tiny particles like, let's say, electrons. So if electron occupies a space in our universe, there is no place for another electron to coexist on the same place. That means the Pauli's theorem basically says that two electrons cannot exist at the same location in the universe. That means by law, as the nature of the universe, two electrons, which are very, very tiny, very, very small, much, much smaller than the atom itself. Even those tiny particles cannot exist at the same place. Therefore, there is a Pauli exclusion principle, and because of this Pauli exclusion principle, if we look at the neutron star, in the neutron star there are neutrons which are not as small as electrons, which are slightly larger. Neutrons are almost the same mass as a proton. Now, if in neutron star only neutron exists, that means as per the Pauli's exclusion principle, within the neutron star itself, even though there is a lot of gravity and a lot of force is pulling everything inwards, in spite of that, these two neutrons cannot overlap the same place. They have to overcome this pressure which is on their head from all directions, because when the neutron star is so small, so dense, everything is neutron, everything is made of neutron, there are no electrons, there are no protons. The pressure within the neutron star is so immense that these neutrons will have to either break apart or will have to repel this pressure which is being exerted by the gravity. So this is exactly the point of equilibrium in a neutron star, where the gravity is very high, but the pressure which is exerted by the neutrons, because they cannot occupy the same space, they cannot start overlapping. It prevents, the law itself, law of universe, prevents neutrons to overlap each other. So, and they cannot, if they break apart, they will actually break apart into further subatomic particles, the constituent particles of which the neutrons are made. So if it breaks apart, it will become something known as quarks. However, if it doesn't break apart, it will prevent gravity to squeeze any further. And that is why neutron stars are very energetic, very, very dense objects, but they exist in our universe. They exist for longer time because the neutron collapse is stopped by this power of which is also known as the degenerative radiation, which prevents the neutron star to collapse further. However, there is a limit. The limit is 2.5 times the mass of sun. We know that sun is so huge, humongous. It's big ball of matter, gas, hydrogen, etc. And many, at least million Earth can fit into the sun, the volume of the sun. And when we measure the weight of the sun, it is actually trillion times than the Earth itself. So much matter can exist in a ball of just 20 kilometers. That means in the entire, actually the mass of 2 suns can squeeze into one neutron star. It will form a very dense object. So our great Indian scientist known as Chandrasekhar, he actually gave the limit, which is known as Chandrasekhar limit. He gave limit to everything, basically all the large things like neutron stars, big star, black hole, etc. So the limit is 2.5 times the mass of sun. A neutron star gravity will be so immense, the neutrons will not be able to hold this gravity and then disintegrate, and at that point in time the neutron star will collapse to become a black hole. So that is why Pauli's exclusion principle was very important to understand at this point in time, to understand if there are mountains on the neutron stars, because the environment is so intense on the neutron star. Whether we can have some aberrations on the surface, scientists believe now that there are, and I will tell you in a minute why there are aberrations. So let's look at the typical layers of the neutron star. Like any other object, the neutron star also have layers. Agree that everything is made of neutron. However, there is a very fine layer of atmosphere, as we call it. This atmosphere is obviously not made of solid, but still it's made of plasma. The conditions of the surface of the neutron star is so intense that the matter, which is atmosphere as we call it, very, very thin strip of plasma that overlaps the neutron star. Very high energetic plasma, which is the fourth state of matter. We know liquid, gas and solid. plasma is the fourth state of matter that exists as an atmosphere on the surface of the neutron star. Now, what this plasma is made of? Well, plasma can be made of any kind of material. It could be ions or stripped of atoms of gases, iron, even heavier material. But plasma does not behave like solid, liquid, or gas. It's a fourth state of matter. So a thin layer of atmosphere exists on the surface of the neutron star. There is a crust also which exists on the neutron star, and the crust is also very thin, extremely thin. Now, when the neutron star was formed, obviously neutron star was formed after a collapse of a large star, many times bigger than the sun, and the collapse of the last star ended in a supernova or a hypernova, leaving behind this neutron star. So, although the mass of the neutron star is twice the mass of the sun, but the original star was at least 20 to 30 times the mass of sun. So, when the supernova exploded, most of the mass was scattered. However, the two stellar masses remained in the core, which became the neutron star. Therefore, the crust may consist of pure iron, which was created in the core of the star prior to going supernova. So the crust is made of iron atom. Again, very extreme situation for iron to exist, but scientists believe that there could be very thin layer of iron atoms which may form the crust. And then you go inside the neutron star where everything is made of neutron. However, this pressure on the surface or within the neutron star, especially when you go deep inside the neutron star, the pressure in middle of the neutron star will be so immense that this pressure, even though there is a Pauli's exclusion principle at work, the pressure will actually disintegrate the individual neutrons into its their fundamental building block, which is known as quarks. And that is why the core is a fluid. It's like a fluid. It's like just like we have earth core, which is made of molten iron. The core of the neutron star is also made of sort of floating quarks, because once the Pauli's exclusion principle is applicable, but then they are not able to withhold their own structural integrity, they break apart into quarks, and quarks can then move around freely and create some sort of a liquid within the neutron star. Now, neutron star, because of this feature, because at the core there are flowing matter, very hot, very energetic matter which is flowing and being bound by gravity. And since there is a flow, and what happens when the very hot material flows and collide with each other, we create magnetism. And that is the reason that neutron stars are not only a very important source of gravity, but also very high magnetism. 1,000,000 times magnetic force a typical neutron star will exert, 1,000,000 times more than what we experience on Earth. And this high gravitational force exists because there are the quark ocean within the neutron star, liquid form, which act as a liquid. It's not actually liquid. It is a very strange material. It's only made of quarks. So over time, when the star was born, it was hot. Although neutron star does not generate any heat, it only retains the original heat when it was formed. So it is very hot. It is very energetic, very high gravity, very high magnetism. Everything is like top of the chart when it comes to neutron stars. Therefore, a black hole can also be formed when the new neutron star actually collide with each other. So oftentimes, these two giants come together, collide immediately, and then they overshoot the limit which has been prescribed, which is 2.5 times the mass of the sun. However, if the two of these guys collide with each other, they will overcome this limit, and they will immediately result into a huge explosion, which we can see from our naked eyes, and resultant body will then become a black hole. So when we want to study these strange objects like black hole and very large heavy objects, although they are very small in size, but in terms of their influence on the universe, they are very large, rotating extremely high speed, uh, many times per second, having very high amount of heat on the surface, very high amount of gravity, and also very high amount of magnetism. These to study these objects in totality, we need different methods to study, and that is the gravitational wave analyzers. The gravity analyzers, basically, because Einstein predicted that the gravity will also flow like wave, just like the light travels in a wave. Similarly, Einstein had predicted that even the gravity will go into a wave. The difference between the light and the gravity is that the gravity waves are huge frequency. That means when a wave is passing through Earth, we will not even feel any bit of the effect, because the wave of the gravity is so huge. It's like many times larger than the solar system itself. So being on Earth is so small, we will not even feel the effect of it. However, scientists find a way, very sensitive instrument they have developed using lasers, and so we are not going to discuss about those things, but then there are instruments like this one, as you see, is known as LIGO, which is meant for calculating the gravitational waves. So far, LIGO type instruments can measure waves coming from black hole mergers and rotating neutron stars, but LIGO is not sensitive enough to understand in totality what is going on inside the black hole or inside the neutron star. If the neutron star is rotating or black hole is rotating, it is actually taking, because of the high gravity, taking the universe around it along with it. And as I said in the beginning, it is known as frame dragging. It is actually influencing the universe around it, the space around it, and that creates a gravitational wave which is propagating outwards. Those waves can be captured by this instrument that you see in the picture. It's known as LIGO. However, anything smaller than these waves, it is difficult. So therefore, we need more sensitive instruments to understand if there are deformation on the surface of the neutron star. Now, the scientists have said, over time, since the neutron star is not generating any heat, it is only retaining the heat, and therefore over time it will start losing the heat. And when that happens, the logic says the neutron star will contract slightly. And even when it contracts slightly, when a neutron star just shrink by 2-3 millimeters, that is enough to cause an earth, sort of a starquake, as we call it. There could be an imbalance on the crust, because the things are getting squeezed, and because of that the crust will break. And because this object is so extreme, even a small crack on the surface will actually result in a huge sort of explosion or some sort of vibration in the gravitational waves. So scientists are now looking at creating new instruments so that we can capture these smaller waves, because if we are able to capture these smaller waves, then this theory will be proven that in case there is a shrinkage of the neutron star, there could be star quakes on the surface. The breakages of the surface, which is made of ions, will break apart. And if that happens, then the whole theory of tectonic plates can also be true. The surface of the neutron star may not be one round ball, but it will be like a jigsaw of material which is fitted together like tectonic plates, as we see continents on the surface of the earth. So even on neutron star, there could be these plates which are fitted together like a jigsaw, and the older neutron star will have more tectonics, more breakage on the surface. Now, I will also like to talk about another incident which affects the earth. If there is a large earthquake, on the surface of the earth, scientists actually can measure the impact of that on the rotation of the earth. A large earthquake happening anywhere on the surface of the earth creates some sort of impact, vibration, motion on the rotation of the earth. And there could be either increase, a minute increase. We don't feel it on day-to-day basis. So scientists use very sensitive equipment to measure these changes in the surface, and they know that in case there is a large earthquake, it will trigger some tsunamis, it will trigger large scale destruction, it will impact multiple places, multiple countries, sometimes entire continent. And sometimes earthquake is so large that you can actually witness another earthquake on the other side of the earth, or experience aftershocks for a couple of days, if not on a single day, at least over 1 week to 10 days to sometimes 20 days. So all of these phenomena has impact on the earth's rotation. So therefore, if there are neutron stars having these phenomena on the surface, which is star quakes, tectonic plate movement, and because the tectonic plates are now colliding, therefore there could be aberrations on the surface where there could be mountains being created, there could be valleys being created, even though these mountains may not be more than a centimeter high on this extreme object. Because of the gravity, of course, everything is getting pulled inwards. But even then, these mountains, when are created because of this tectonic plate movement, and whenever there is a star quake on the neutron star, that may impact the rotation of the star. That means if we are observing a neutron star and it is rotating at certain speed, and if it experiences a star quake, the speed of rotation will undergo certain changes. And to really record these phenomena, we need a much more sensitive equipment than LIGO. And then once we have that, then we will be able to effectively measure all these phenomena. Once we have that knowledge, then we will be able to examine these celestial objects and come up with their properties much more accurately, because they are very extreme, they are very intriguing, they are almost unbelievable objects. And therefore, if there are tectonic plate movement, there are mountains, there are valleys on the neutron star, it will open up a new chapter. And the best way to study is study the creation of these mountains, creation of these star quakes, creation of these tectonic plates on the surface of neutron star. Because whatever happens on neutron star, if we study with the sensitive enough equipment, gravitational wave equipment, then we will be able to basically measure a whole lot of properties about neutron star. It is important to understand neutron star, because if the two neutron star merge, then we get a black hole, and we know very little about black holes also. At least neutron star we can predict, okay, there are these properties of the matter. There could be quark ocean inside, there could be surface, there could be atmosphere, there could be mountains, valleys, tectonic plate movement. But for black hole, there is absolutely no knowledge humans have today. So friends, I wanted to discuss this very intriguing subject in this science show. If you have any questions, any observation, feel free to send it across, and I will meet you in the next one. Thanks for watching.